So we're going to continue on with our discussion about the internals of parallel streams. Last time we talked about parallel stream internals, we talked about what can change and what can't change, and that led to a discussion about things like splitterators and to discussion of collectors, as well as the way in which the common fork join pool actually processes the results in various ways and how you can control or not control some of those dimensions. So what we're going to do now is we're going to start talking about how a stream partitions data into chunks. So it'll take a data source like an array list, for example, or a linked list, and then chop it up into pieces to be processed in parallel by the common fork join pool. As we've talked about a couple times before, the means for doing this partitioning is something that's called a spliterator, which is short for splittable iterator. And so a spliterator is what Java Streams uses to break things up into pieces. We're going to focus here primarily on how parallel streams use splitterators, but we have to briefly reiterate how streams in general, sequential streams and parallel streams, use splitterators as well. So earlier we discussed how splitterators can be used to traverse the elements in some source. And the way that that's done is by calling the splitterator factory method, as we see here, and then the try advance method. And try advance is what's used to walk through each element in the source and then do something with it. We're now going to talk about how you can use another part of the splitterator interface, which is called try split, in order to partition all the elements in a source up into chunks. And we'll see here that the try split method is what does this. And this method, this try split method, is called internally by the streams framework. So you don't typically call try split yourself unless you're implementing your own splitterator, but it's called for you by the streams framework. So here you can see what we do. The goal of try split is to try to split the input evenly if possible, and it does a little sanity checking as part of that process. So its goal is to split the input up into two chunks, hopefully evenly sized, and then it'll return a splitterator that covers the left chunk, and then it leaves the existing object to cover the right part of the chunk. And that's why it's ideal if it splits it evenly, because then you end up with things that are split in half, and then you end up with a nice tree that's only log n deep, if you recall your algorithms class. A splitterator doesn't require synchronization, typically, nor does it need to join anything. That's done by later phases in streams. So the reason why synchronization is not required is because it's only called in one thread of control. Try split is called recursively until all the chunks are less than or equal to the minimum size. So once the minimum size has been reached, then it returns a null, which is an indicator to the Java Streams framework that there's no more chunking to be achieved. We've reached atomic sized elements, and then go ahead and call try advance on the parts that are left over. Typically, the minimum size with Java collections by default is 1. So it splits it up into atomic sized elements of 1. If you don't like that, you could write your own splitterator to do something different. When try split is done, then we know that we've reached the minimum size. Okay, so here are some examples of splitterators that come out of the box. So here's the splitterator for array list. So the array list splitterator, which you can take a look at the link down at the bottom of the slide, has a couple of methods. And the first method we're going to look at is try split. So what it tries to do is it tries to split the array evenly until there's nothing left to split. How does it do that? So it basically takes the low and the high, and it adds the low and the high together to create the midpoint. That's basically a divide by 2. It's a right shift by 1. And so what we're going to do then is we're going to say, is low greater than or equal to mid? In other words, have we split ourselves down to below the atomic size or to the atomic size? If so, return null. Otherwise, what we do is we make ourselves a new splitterator, which is going to cover the left-hand range, which is low to mid, and then the existing splitterator will be from mid to high. So this will split in half. You can see this is very efficient. It takes constant time to compute the midpoint and constant time to create a new splitterator that splits on the midpoint. And then here's the try advance method. This will try to consume a single element on each call. So it'll go ahead and call the accept method on the consumer parameter, which is known as the action. So that's pretty straightforward, nothing too surprising there. Now let's go ahead and take a look at the linked list splitterator. And as you can see here, the linked list spliterator, which has the same interface as an array list, is a lot less efficient. And that's because there's no easy way to find the midpoint of a linked list without traversing through the pointers to find the midpoint, which would take a long time. So rather than do that, instead, what the linked list implementation of the spliterator's try-split method does is it splits the list up into batches rather than even taking a shot at trying to break the list up in half each time. And there's all kinds of extra stuff going on here. We're splitting things up into batches. There's some additional copying that takes place. So it's just not a very efficient way to do things. And then the try advance method also will try to consume a single element. And you can see it's got a little bit more ceremony here because we've got to deal with the fact that this is a pointer and we have to adjust things and so on and so forth. So much more complicated and therefore, not surprisingly, less efficient than the array list spliterator, as we'll see here shortly. We'll cover some implementation details of parallel splitterators in upcoming lessons. So this is just an overview of the behavior of splitterators and then talking briefly about the array list splitterator and the linked list splitterator, which we'll then talk about here shortly as well and look at the performance differences.